All right, here we go with the Phyzjob Parallel Circuit problem. This is number 1. Similar format to the series circuit problem, but again we have different rules for parallel circuits. Specifically the voltage loop rule is a little bit different, and to get total current and total resistance we have different equations. So again, this symbol, this little cursive E, this stands for electromotive force, which is also like the voltage. Let's assume this is a battery. So we have two paths. Path 1 has one resistor on it that's 16 ohms. We have path 2 that has resistor 2 on it with 24 ohms of resistance. So we're going to have less current going over or going through branch 2 than we do on branch 1 because there's more resistance on branch 2. The total current is going to split into both branches and then join back together to return to the negative terminal of the battery. So let's start with the equivalent resistance. Again, equivalent, this term here, means, if I can get this, total resistance. And we can't just add them all together for parallel circuits. We have this fancy equation. So here we go with substituting in. You have to multiply the different resistors together. So in this case, we have R1 and R2. If you had 3 branches, you would multiply all 3 together. This is kind of like finding a common denominator. So we would have 16 ohms times 24 ohms. And then we would divide that by 16 ohms plus 24 ohms. So in your calculator, you're going to want to add the denominator together before, unless you would like to input parentheses in your calculator, but it's a little trickier. So that's going to give us 16 times 24 divided by 24 plus 16 is 40. So 16 times 24 divided by 40 would give us a total of 9.6 ohms if we round to the 10th place. So that's going to be our total for part A. So notice that the total resistance in this case is less than both resistor 1 and resistor 2, and this is because as we add resistors in a parallel circuit, the current is going to increase and the total resistance will decrease. Kind of like adding lanes in a grocery store, you're going to increase the flow or speed of which people exit the building. Part B, the total current in the circuit. So here we have to use total voltage, total resistance from the previous problem, using Ohm's law to solve here. So here we go, equals 12 volts divided by 9.6 ohms is going to give us 1.3 amps. That's our total current. The total current is going to split across each branch and then join back together in this last segment. For part C, power dissipated in R1. So we're choosing from the following equations: power equals current times voltage, power equals current squared times resistance, or power equals voltage squared divided by resistance. So based on the information that we know the resistor or resistance on branch 1. We also know the voltage. So we're going to use this last equation here. Let's see if I can highlight this. Okay. So we're going to get voltage squared, which is 12 volts times 12 volts over 16 ohms. So we'd get 144 divided by 16, which should give us 9.0 watts. So that's the power dissipated or used over resistor 1. Now remember the voltage loop rule. The voltage loop rule says voltage gain from this battery or voltage source has to equal the voltage drop in any complete loop. So in a parallel circuit, you could have this as a complete loop, this smaller one, or you could go across resistor 2 for the bigger loop. In any case, the voltage drop over both resistors has to equal 12 volts. So that's where we're getting that value. For part D, we're doing a mini Ohm's law equation for resistor 2. So we know the voltage drop of 12 volts, and we know the resistance of branch 2, which is 24 ohms. Easy math, 12 divided by 24 is going to give us 0.5 amps. So this is the current flowing through branch 2, and our total current is 1.3 amps. So 1.3 minus 0.5 amps would give us 0.8 amps, which would give us the current across branch 1. So that's it for the Phyzjob parallel problem. If you have any questions or comments, please leave feedback below. Thank you.